In the last lecture, we have covered the logical operators and its working process, along with that, its operator precedence and associativity in comparison with arithmetic operators and relational operators. Fine. So now onwards, for the last next three lectures, we're going to see the branching. Okay, how can we achieve conditional statement? How to write the program? Okay, we'll take some program statements and we'll implement it. Right. So now we're going to see the mix of everything, whatever we have learned. We're going to see the use of data types, mix of data types. Then we also going to see the use of operators, as our basic building blocks are done, almost done. We'll see the couple of more operators are there later. Then we also going to see the conditional statements. So in C programming language, there is a basic building blocks, or there is a statement which is very popular by the name of if and else. Those statements are called conditional statement. We can also call them branching, as well as you can also call them true false statement. So from the name, I think you get to know the idea a little bit here. When you say true false, that means we're going to use these two operators, right? One is relational, that we have seen already, and another one is logical operators. Okay, so what is actually if and else statement? When to use if else statement? As of now, whatever the program, okay, that we have written in the GDB compiler, uh, you can see that a program flow started in one direction and ends in one direction. Means program execution starts with main, it is follow top to bottom approach, right? We have taken some variable and we have initialized some value, and we have performed some mathematical operation, right? And then simply we printf the particular variable or identifier. So you can see the direction of the execution is top to bottom in one direction. We have no decision to make. Okay, only one direction, one directional execution of the program. But this if else statement gives us more flexibility to build a logic based on a certain condition, and where decision making is little become very handy. So the if else statement is a fundamental decision making tool, okay, in programming. So you will won't see any no logic that we are not using if and else. Minimum if and else normally we are using almost in all programs, right? It is also a best suited when a situation occurs where conditional logic determines the flow of the execution. Flow of the execution, please note down this point. Flow of execution, what it means, see, flow of execution means, so when our execution started from the main method, then here you can see execution started from the main method. So this is our main, and anything can be done once it's entered to the main declaration. We have, right, we have some scanf stuff, and suppose we have some expression with the operators and operand, and then followed by some conditions are there. So how we write the condition? We have seen that conditions normally we are written with the expression, okay, like a greater than b, or suppose a greater than b and c less than d. Okay, so these are called expression. So, and that expression, before computer move before compiler move further to execute of the code, it need to take some decision here. So we called it decision statements or decision taking program. So that's why it is called decision making tool. So here some decision need to be taken by the compiler. So now remember, this decision can be of two type, either as a true and either as a false, right? Only two type, either true or either as a false. So now, once this particular expression is going to evaluated, right? Once the expression is evaluated, there will be two outcome. One either as a true, and if the outcome is not true, so definitely the outcome will be false. Okay, we have already seen. Okay, suppose if I write a greater than b, and if I initialize a equal to 3 and b equal to 7. Okay, so if I now replace their values, 3 greater than 7, 3 greater than 7 is false, we all know. So there is two possibilities, either there is a true or either there is a false. Okay, so now how many path of execution? If this condition returns me true, I need to follow one path of condition. If the condition returns me false, I need to follow another path of execution. So there are multiple path of execution, or at least two path of execution. Two path of execution. Okay, at least two path of execution. Okay, I hope this point is clear. At least two path of execution, right? Okay, fine. So once the program execution start, it's do the stuffs as per our requirement. Then when there is a time that we need to take the decision, so it enters in a certain condition. So that condition will be written using if statement. Using if statement. So there we're going to put the condition, and the condition will be evaluated by the CPU normally, definitely, and then there will be two path of execution. Okay, so if the condition is true, it will follow one path of execution. If condition is false, it will follow another path of execution, right? Okay, so when condition is false, we normally write it using the else case, and when condition is true, we consider it as a if block. So in your code, we're going to see that now there are two different block of code. Once the condition will be written here, then its block going to be executed if the condition is true. If the condition is false, then we're going to see another block of code going to be executed, so that will be written with the else. Okay, so either your program control will enter here. So if it is not entering here, so definitely program control will entering here. So here you can see there are two different path of execution, and the condition, okay, the condition that I have mentioned a couple of times, that condition going to be put here. Okay, so we called it, no, this is a flowchart actually. Flowchart which tells us the flow of execution of the code. So conditions we're going to be put here, right? And based on the condition, if it is true, it is also possible that my if block may contain one or many statements. Similarly, my else can also have one or many statements. Okay, so all the statements will again execute in this order, top to bottom, right? And once the else block is executed, here I have just mentioned that program execution will stop. It is not necessary that your program execution stop after the else. It will follow normally a normal path of execution if there is no other if and else is written. Okay, so definitely it will lead to the it will end the program execution. So it is the entry point of my main, and it is the exit point. So you can say this is the main block. Okay, and this will be my if block, and this will be my else block, right? So now let us take one example to discuss. So let us take this program. Write a program to check a given number positive or negative. Okay, so let's go to the GDB compiler and write and check. So we'll take one number and we'll take input from the user. And let us take input from the user. Enter a number. Don't forget to use the ampersand, is the address of operator. Done. So it will take in the input. Now here we need to test the number. Test the number. So how to test the number? We're going to use if statement. So how to write if? So here write down the condition. So we need to know the logic here. How to test? How to test that a given number is positive or negative, right? So we all know that numbers are greater than 0 are qualified as positive, and numbers are less than 0 are qualified as negative, right? Okay, so which operator are you going to use? Relational operator to build the condition. I hope now you understand the purpose of relational operator, why I have discussed it later. So where is the value? Value will be in the num. So I have written num. If num is greater than 0, we're going to start the block of if. So let us just print percentage %d is a positive number. And now suppose if suppose user entered a number in negative, okay, so that is the reason I have used integer. I did not use unsigned here, so it is by default signed. Okay, so we need to write this thing in else printf and write percentage %d is a negative number. Done. Simple. So this particular part will look for the true case, look for true case, and if true is not satisfied, it will go for the false case. So we normally write the if condition for the by keep this point in mind, that condition will give me the true value, and if it is not true, so automatically program will execute the else part, right? So let us execute and see. It's waiting for the number. I have entered 8. It give me 8 is a positive number. And now let's run again. If I give -9, it's give me -9 is a negative number. Okay, so how this execution has been done here? Let me just show you again one last time. See, you suppose you have entered a number 9. Okay, so we don't know what user entered. It is a positive or negative. We don't know that number in the RAM. It is stored against the name num. Okay, so we have referred through the scanf, so that memory block have some address. Assume this is the address of the block. So it referred to that address, so that value is stored into the scanf through that particular memory. Now here we are checking. So what is the num? We do not know whatever the value. Suppose num you have entered 9. So we are checking 9 is greater than 0. Answer is true. So if it is true means it will have 1. So it will print this. So my program execution start here. It enters into the if. So if it enters into the if, else will skip. Else will skip by the compiler. So automatically from there it will jump outside of else. Okay, so program execution starts. We have written the condition here. What is the condition? Num is greater than 0. So if found that condition is true, so condition is true, the body means that particular printf is executed and it stops the execution. Okay, and now suppose that if I entered the number as -5, in that case this condition will be false, so it need to be follow another path. So this one will execute, it will follow this one, the else part, and definitely my program will stop after the execution. So this is the body of else, this is the body of if. So this is the way if and else is actually works. Sometimes it is also found that it is not being necessary to write the else block in your code. Okay, so let us just take a problem statement. So problem statement is like that. Check the uh, given number is 5 or not. Okay, so what if I build this particular logic without if and else? Okay, So I'm just going to put this code in comment. I'll share this file so that later you can refer this code for your practicing purpose. Okay, so my scanf is there. Now if I write if num equal to 5, now we can print here printf percentage d, the entered number is, so you can check what the number we have entered. Now suppose I am not going to write else, what will happen in this case? Okay, so let me just erase it. Now execute this. So it is asking to enter a number. I have entered 4. I see no output. Okay, because there are more than one path of execution. One path of execution it will follow for the given number is equal to 5 or not. If number is not 5, I will not see any output. Okay, so if you did not include else, this might be the situation you may face. So then better to add an else here. So you can see the entered number is not 5, you can say, or is not 5, simple. Now run this. So if I now write 2, so the number is not 5, correct? Okay, so move further in the simple if and else. Another point you should remember, as we have just seen, a program can be written. We can use only if block. My code will execute. You can see if I execute, yes, I'm taking input. It give me either output or not output based on the condition. But my code doesn't raise any issue. No error is there. But we cannot write an else without if. So here it is. Suppose I have written an else. Okay, now run. So see, look at the error. Remember, else cannot be written without if. Else always come for a true case. You cannot tell anyone that the statement is false unless and until you know the true statement. So else cannot appear alone. Else must be followed by an if. Okay, so you can see there is a else without previous if. Else must be followed by an if. Okay, if should be there and then you can write else. So writing else is optional. Okay, remember it is an optional. Based on your program outcome, you can decide that you should write else or not. Now let us take another example. Write a program to check number is odd, even or odd. Okay, so again I just going to put this thing in comment. Even or odd. Okay, so let us first check how to know a number is even or odd. Okay, so see, if I have a number 30, how can I decide this number is even and either this number is odd? How to do? In mathematics, how we have checking this? So normally, suppose the numbers last digit, okay, is 0, 2, 4, 6, 8. These are the last digit of a given number. We can easily say these are the even number. Else other numbers are odd. Otherwise the numbers are odd. So now question is that how can we know that the number entered by the user, how many digits are there? It is very difficult for us to predict. Okay, a user can enter a number of one digit. Okay, so it can enter a number from between 0 to 9. He can also enter a number between 10 to 99. Further, he can also enter a number 100 to 999. Similar way, he can follow any number. So it is very difficult for us based on this no logic. If we build the last digit is any of this number. Okay, so for that we need to first extract the last digit. extract the last digit. Okay, so if user entered 3459, we need to extract the last digit, then only we can apply this logic. Okay, so apart from that, what we can do, suppose if a number is even, suppose if I take a number is even, that number if I divide it by 2, you can see there is no remainder, no remainder, right? But if for an odd number, if I divide that number by 2, there will be always a remainder as 1. So if you remember, in arithmetic operators we had an operator called modulus, okay, which gives us the remainder when I divide that number with something. Okay, we get a modular, we get a remainder using the modulus. So same thing we can apply here. Okay, so here, so for a number is odd or even, what we can do, let us try to understand. Now we suppose our number is num. Okay, so we'll check modulus by number by 2. There are two solutions, either 0 or either 1, right? So there are two solutions, either 0 or either 1. So for we look for even, suppose we look for even, so this is our true case. This is our true case. Okay, so if this is true case, we'll look for this with the if. And now suppose odd is the false case in our case, so we'll go with else, right? So how to check a number is 0 or not? How to check the equality of two values? To check the equalities of two values, we're going to use equality relational operator. So if the given number modulus by 2 equal to 0, what we are going to claim that it is even, and else scenario. So this is our if, and in case of else, we no need to write any condition. Even we cannot write a condition with the else, we simply going to print it is an odd number. So now here do not confuse that there are two operators, one is this, another is this. We have already discussed that arithmetic operator higher in precedence with respect to relational operator. So definitely this particular part will be evaluated by the compiler first, and whatever the outcome we got it here, it's going to be compare with this, and outcome of this expression either will be true or false. So if it is true, it will go with the if, and if it is false, it comes with the else. Okay, so let's build this logic here. Okay, so let's build a comment. Logic to test a number is odd or even, right? Okay, fine. So now let us build the logic. We have the number with num modulus 2 equal to 0. So what we can do, printf percentage d is an even number, or else. Remember, this is not Python. Do not use directly indentation. We have to do with the block coding. We have to use curly brackets to write the body of if or body of else. It may contain one line or more than one line of statement. Better to use the blocks. Okay, percentage d is an odd number. So let's run this. Okay, so let us enter a number 89. 89 is an odd number. Run it again. Suppose I have given 44. 44 is an even number, right? So if I enter -8, it is an even number. And if I enter suppose -9, it is an odd number. So code works fine. Okay, another point. Now last point, we're going to end this demonstration here. In the next demonstration, we're going to see code required more than one condition. We're going to introduce if else ladder. There are various ways we can write the if and else. Here I have used the simplest form of if and else. Okay, only one condition. If condition true, the body of if will execute. If condition is false, body of else will execute. What happened once the body of if is executed? After executing the body of if, program control will jump directly outside of else block. Simple. Okay. Another point, if suppose your if and else block contains only one line of statement, right? So in such case, using of block coding is not necessary. It's become optional. You can also write the code like this because it has only one line of code. But more than one line of code, if you want to execute, in such case you have to use curly brackets to start of the body of a block and to end of the body of a block. Run this. Okay, 2 is an even number. Got. Now run this. 2 is an odd number. Okay, fine. Clear? So I think you have understood how to use if and else, and we have started with the very simple condition where is only we have written only one condition. Okay, we have not mixed with the complex condition with the logical operators. Simply we are using one relational operator to get to know the outcome. Okay, fine. I hope you like this. In the next video we're going to see little bit more number of if and else. We called it if else later. Okay, so have a nice day. Thank you.